stuff. All right, well, good morning, everyone. Thanks for joining us today. Really excited to present to you about permeable surfaces and really maybe more specifically permeable pavements. Just to kind of give you an overview of what the topics are that we're going to be going over during this is we're going to first start out with an introduction to permeable surfaces. Some of you may be familiar with permeable pavements, may have used them before. Others of you may be brand new to this. And so we want to make sure we kind of cover the basics there. Then we're going to kind of go into some of the commonalities among different types of permeable pavement systems. There's a lot of differences at the surface, but there's a lot of things that are pretty common with the permeable pavement systems as far as what their intended functionality is, how they're designed, and so forth. And so we're going to cover that then. Then I'm going to turn it over to my colleague, Jessica Brusso, who's going to talk to you about modular pavements and the opportunities that you have with using those types of options. And then I'll come back and cover poured in place pavements. And we'll talk about some myths versus reality about permeable pavements. So there's several different types of permeable pavement materials or permeable surfaces. And so some of these are shown here. Mostly the most common ones that we see are porous asphalt, porous concrete, permeable interlocking concrete pavers, and then some types of grid pavement systems. So just to kind of differentiate here, the porous asphalt and pervious concrete are poured in place systems, whereas permeable interlocking concrete pavers and grid pavements, those are more of your modular pavement systems. Now the pervious concrete can also has some new options as far as being modular as well, and I think that Jessica is going to cover that a little bit in her section. But these are the most common types of permeable surfaces that we generally see. There are more than what we have shown just here, but just to kind of keep it at a narrow focus within the most common types of materials, we're going to kind of focus on sort of in general these. Keeping in mind that the permeable pavements, the way that they function, even though there are different types of materials on the surface, they generally function very similarly. So with each of these types of pavements, the concrete grid pavers are just another type of the grid pavement system. We have permeable interlocking concrete pavers, porous concrete, and porous asphalt. With the concrete grid pavers and permeable interlocking concrete pavers, the configuration of the pavers allows for void spaces at the surface for the water to either flow between the pavers or through the paver itself. Concrete grid pavers, these are oftentimes the lattice blocks that you might find at home stores that you can kind of lay down, made out of concrete, probably about that wide by that long. And so in these cases, the concrete grid pavers could be either filled with sand or a pea gravel, and we call that a bedding material. The permeable interlocking concrete pavers are generally they're going to have gaps in between the pavers or sort of where those pavers meet, and the layers underneath are typically going to be sort of a bedding layer right below it. There can be sort of what's called a choker course of stone, and then a reservoir course, sort of an even larger stone, and then you have the subsoil down below. Porous concrete and porous asphalt are a little bit different in that they are generally put down almost directly on top of the choker course. They kind of don't necessarily have the bedding layer needed for it. We'll explain a little bit more about that when I get into those pavement systems. But essentially, the functionality of permeable pavement systems for all these different types of surfaces is that the surface is not restrictive to the water that's coming down. So the infiltration rate through the surface is greater than the rainfall and any runoff that's coming onto them. That allows the water to drain very quickly into this stone layer below that has high porosity, high storage, that can then over a longer period of time exfiltrate into the soil below, or if we have under drains, it can kind of exfiltrate through the system in that way. Show some examples of that here in a moment. So looking at the typical designs, we're going to kind of just cover this very quickly of how these might be configured. So you have, whether you have porous asphalt, porous concrete, or pavers, or even concrete grid or grid pavement systems, Essentially, you have that at the surface. Then we have sort of a choker course. And what the choker course does is it really kind of provides a finer level bedding for either the bedding material or the pavement to kind of go right on top of. It also has some storage available, but the reservoir course is generally going to be your dominant volume of storage. So that reservoir course is usually going to be free of any fines. We call it open graded. And I'll talk a little bit later about the different size particles. And then the water is able to exfiltrate into the subsoil. And oftentimes we don't want this to be overly compacted. So we'll need to have the structural support for that soil, but we want to make sure we still maintain the necessary infiltration rate out of the system if we're relying on that for our storage recovery. So if we have poor soils or our soils are not as good at infiltrating as we need them to, we may need to help facilitate that by including an under drain. And so we can do this by basically installing a pipe. Usually this is 4 to 6 inches at the bottom of that reservoir course and connecting it downstream to the stormwater system or a surficial outlet. This allows for any water that's just not percolating into the soil quick enough to kind of go through the under drain. And this allows us to more rapidly recover that storage volume if we're not able to do it through the subsoil. Yeah. And then if we want to have greater infiltration and we can have an upturned elbow, this allows for a greater amount of storage to build up in the subsurface before it exfiltrates and drains out at the surface. This is a design that's kind of taken off from some of the designs that are used in bioretention that help to facilitate a saturated zone for denitrification in the bottom of the storage zone. But this, in this case, helps to basically retain more water in the storage zone and force more water to exfiltrate. In some cases, you're going to have situations where the soils are just, you don't want water infiltrating. And it may be that you've got a high water table. It may be that the soil texture is just not suitable for when it has moisture in it to be stable enough. And so in that case, we probably want to include an impermeable liner. That will prevent water from migrating into that subsoil and starting to affect the structural support. And so the under drain here will basically be the only pathway out of the system. And in this case, we're really just relying on permeable pavement as a detention system. So we're not really eliminating the volume because that volume, once it infiltrates rapidly into the system and then slowly drains out, that's still going to have to go into either a storm drain system or some other volume control area. But we do get some water quality benefits through the filtration, the physical and chemical processes that can occur within permeable pavements over time. When we look at permeable pavement system design, there's two aspects that always have to be considered, or the primary ones. And whichever one is the most the most restrictive or the most requires the greatest profile essentially is the one that drives the design. So the great thing about permeable pavements is that you can use it for your stormwater management, but as well you can use it for traffic loading. And so there's a balance here between the structural loading and the hydrologic performance. And so you kind of have to design for both of those. So you go through sort of a structural analysis, determine essentially based on the different layers and the strength of those layers and the thickness to determine what the structural depth. So for example, you'll have a pavement layer that's pretty fixed. You'll have maybe a bedding layer, maybe a choker course, and then a reservoir layer. So that is your full profile. But maybe you have to have a greater volume of water than what is in the reservoir course. And so that would be a situation where your hydrologic design, would actually drive the design, and you may have to increase that depth to meet both the hydrologic and structural requirements. Now, water quality design is another aspect that can be incorporated. We'll touch on that a little bit later as far as how that can be integrated into the design here. But essentially, this is sort of a decision tree that walks you through what the main aspects of structural and hydrologic design are for permeable pavement systems. The typical materials that we find within our subsurface layers are the stone sizes that you see here. Oftentimes, number 8 stone, we might call this a pea gravel. This is used as a bedding for interlocking concrete pavers, and also to fill the gaps between those pavers, and sometimes even for the grid pavement systems. The choker course here is intended to kind of choke the stone layer that is above what is the reservoir course down below. The choker course has a smaller diameter than the reservoir course, but it's larger than what the bedding course or the pavement material would be on top of it. So it kind of chokes it or prevents it, locks it, so it doesn't migrate down into the reservoir course. And you can see that the reservoir course is a fairly large stone, 2 to 3 inches for a lot of those aggregates. Usually want to have high angularity, and this gives it a high porosity, usually on that 30 to 40% void space within the reservoir. And that's where our volume of storage can be found. All of these you're gonna want these all to be open graded. And that means basically free of fines. So the issue with fine particles in our aggregate is that once it's installed, those fine particles now are in the system. And as water starts to move through and wash those fine particles down to the bottom of the basin, they can get trapped at that subsoil surface and basically clog that. And then it's basically has to be completely ripped out to actually remediate that. So we want to avoid that ahead of time by preventing our stones from having those fine particles with them. Looking at some design considerations, I'm going to come back to this at the very end, but this is a reference in here, the Permeable Pavements book that was developed by the Permeable Pavement Technical Committee, which I'm a part of, that is with American Society of Civil Engineers. We are actually in the process of updating this. This was released in 2016. And we're looking at probably next year to release an updated version of that. But some things to keep in mind, there's a lot of good information in that document. A lot of what I'm presenting today comes from information that we include in there. So talking about and kind of considering design considerations that are common to all of our types of permeable pavements. You want to kind of look at, number one, checking the requirements and guidelines for permeable pavements. Identifying sort of what your site conditions and constraints are. So what are your soil types? What is your traffic loading? Those kind of factors. What's going to happen here? Then you want to identify the design conditions, constraints, and needs. And then specify the construction requirements. Construction is a critical part of any type of permeable pavement system. It's such a narrow window in the overall life of the system, but it has such an impact on how the system actually performs. And then considering, even during the design process, how long-term operation and maintenance will be performed. So some things to think about with site conditions and consideration is locating it on site. So for example, one thing I'm going to mention a few times is that oftentimes permeable pavements don't have to be the entire pavement area. So you notice this upper left-hand figure, you have the main roadway in the center and the parking stalls are on the sides. We often see sort of a 1-to-1 impervious to pervious ratio. You can go up to as high as 5-to-1, but something to keep in mind is that is going to accelerate the clogging if there's a sediment load that is contributing to the surface there. You also want to look at what your structural loading goals are. You'll want to design this differently if you have just vehicles parking on it versus having regular, heavy vehicle traffic on a regular basis moving through there. As you notice, sort of in the upper right-hand corner, I'm not sure if you can see in the back, but it's a FedEx truck on this permeable alley. So they designed it to support that heavy loading that it's coming through there, but that has to come into play during the design and designing for that structural loading. And then looking at our stormwater management goals, whether those are volume or water quality type goals, and then determining if our soils require us to include an under drain or an impermeable liner, and making sure that that is included in that design process. With the structural design, we're typically looking at basing in most pavements are using the AASHTO flexible pavement design. This applies to grid pavers and interlocking pavers and porous asphalt. However, with porous concrete, and I'll talk a little bit more about this, it is actually a rigid pavement design because it doesn't flex like a lot of the other pavements can do. With the structural design, we're looking at what, one of the driving factors is going to be the total traffic load over the design life. So the total number of axle passes or easels, equivalent single axle axles over the system. And then looking at the strength and thickness of each of the materials in the profile. So that's going to, especially for the flexible pavement systems, accounting for the strength and thickness of those materials is what's going to give us our strength of the overall pavement system. And then considering what the soil conditions are and this underneath the system and whether it's going to remain wet or stay dry for a while, that is going to drive a lot of the factors as far as the ability for that soil, that in situ soil, to support the permeable pavement system above it. When we look at the hydrologic design, we're oftentimes designing for using a design storm to look at what the performance of the system is. As you said, when pavements are maintained and free of sediments or fine particles on the surface, they are not going to be limiting to direct rainfall intensities that we experience. You may have, if you have a very high impervious to permeable pavement area ratio, you may, in some really intense events, have a high enough runoff rate that could get up to the limit of the surface infiltration rate, but that would only be in very limited situations when there's probably some maintenance that needs to be done on the surface anyway. So the storage that we calculate here is determined based off of the porosity within each of these layers above. So the reservoir course is typically 30 to 40%. Choker course is typically around that as well. And then when you get into the pavements, they typically range from as low as 7 up to maybe as high as 20% for some of the poured in place materials. With storage recovery, this is where the subsoils come into place if that's how we're draining the system or recovering it. We can have it as an underdrain, and I'm not addressing that here, but that's just essentially the hydraulics limited by the grade, slope, and diameter of the pipe. With storage recovery, we typically are looking at somewhere between 24 and 72 hours with these systems. If it is infiltrating, we want to be aware of making sure that we have sufficient separation between the bottom of the reservoir course and the seasonal high water table. This allows for that void space between the bottom of the reservoir course and the seasonal high water table to fill with the water that has been captured during the intense rainfall to migrate into that space if there is a seasonal high water table, and then that storage in the pavement system to be available after the subsequent storm event. With water quality design, we can use permeable pavements pretty effectively to address a lot of our water quality concerns and issues. Depending on how we are utilizing permeable pavements and how, particularly what the fate of the water that infiltrates that pavement system is, we can achieve several pollutant reduction goals. Permeable pavements are really good at reducing pollutants from first flush and addressing sort of the TMDL goals. If you remember from some of our previous talks or webinars, many of the pollutants that we are concerned with are not coming from those large events, but those regular, smaller afternoon storm events, particularly some of our nutrients. Permeable pavements can help to address these water quality goals by eliminating some of the volumes that would be discharged. Now, that oftentimes get infiltrated into the ground below. And we can have the filtering of these particulates and the biological and biochemical breakdown of these pollutants into the soil. One question I get sometimes is the concern about metals and other pollutants that infiltrate into the ground. And what research has shown is that most of those pollutants, if they do make it through the permeable pavement layer, if they're not trapped at the surface in the sort of the material that's right at the surface, and they make it down to the bottom of the reservoir, then it gets trapped in the first 6 to 12 inches of soil just below the reservoir there. So there's not usually a concern with the migration of the pollutants. Permeable pavement, I'm going to come back to this over and over again. Permeable pavement is a filter, and it's always important to recognize that. And what filters do is they trap particles, but they also clog as they trap particles. And you can see sort of an example that I'm holding there with the particles that have built up over time, the organics that have been trapped, and they need to be removed. But if we're trapping those nutrients and pollutants, we have to be aware that we need to remove that on a regular basis. Thermal pollution is another sort of more specialized type of pollutant in certain areas where, particularly in the summer, the high temperature of runoff coming off the pavements, permeable pavements can be effective at reducing that, as well as trapping salt in certain areas. So it's important to consider sort of the specific site conditions that you have here. So on the left, we've got a coastal permeable pavement system where there's a lot of wind-blown sand, and obviously they haven't been keeping up with removing that sand from the surface, and so we need to think about that and account for where that sediment's coming from. On the far right, we have a church parking lot where essentially they have a very high impervious to pervious ratio. And essentially you're just kind of focusing all of that runoff and all of the sediments that are being generated off that pavement into this narrower, smaller area. And so it's important to keep that in mind as far as projecting for maintenance and how much your area of impervious to pervious, what that ratio is. With the alley here, that's got to be accounted for with the traffic loading. What type of traffic is going to be in this location? What's the weight and frequency of these heavy vehicles so that you have a stable system to support that loading? So, one of the things is making sure that if you have surface runoff, that you are anticipating this during the long-term operation maintenance of the system. Particularly, this can be not just sand and sediment particles, but this can come from organics like leaf drop and grass clippings. As that breaks down, that organic material works to trap particles more and more effectively over time. Construction activities are a big concern during the installation process. As you can see in the bottom right corner, we have a sediment fence here, but obviously isn't working very well with the exposed soil that has kind of gotten through the sedimentation fence and now clogged the surface of this permeable pavement system. So making sure that those particles, those adjacent areas are stable are stable so that you don't have these type of situations happening. Contaminant potential, just thinking about any hot spots. So for example, wouldn't recommend putting permeable pavement in a gas station where you are filling up cars. Now areas that do not drain that filling area, but are still on the same site and really don't have a need for that or a risk of fuel going onto the surface, that might be okay. I've actually seen some examples of that where they are isolated from that area. But also being careful with vehicle maintenance areas and industrial facilities where pollutants can either infiltrate into the subsurface or enter into the storm system if they accumulate in the permeable pavement system. Not too big of an issue in Florida, but we do run into it from time to time, but considering sort of the topography and the slopes. So if you think about it, you got this high porosity reservoir underneath, and essentially if that's on a slope, water can infiltrate at the upper end and then basically flow very quickly down to the bottom, build up and overflow at the surface. I've seen a project that I was monitoring one time that had that kind of configuration, and it had about a 6 feet of drop over a 1% slope over about 600 feet. And basically, whenever we had a large rain, it would overflow at the bottom. They didn't install basically check dams or these baffles to hold the water back at intervals of the drop. And so this is a recommendation if you do have some topography on the site or some elevation change, and you want to use permeable pavements, you can. It's just important to consider where water is going to flow once it enters the system. Because if you're not on a flat surface, you can have sort of that flow going down the slope and either down to one side. And that can effectively reduce the overall utilization of the storage there. Again, we want to keep at least 2 feet of separation from the seasonal high water table or whatever restrictive layer is below. But some other things to keep in mind are potential for sinkhole settings or sinkholes. If you have focused infiltration in a location, it just might be something to check on and do and investigate during the geotechnical investigation of the site. You also probably want to have some separation from other systems like wells and septic systems or subsurface structures. We typically don't recommend infiltrating water within 10 feet of the foundation of a building. And if there are concerns about groundwater contamination, that's going to be pollutant and site dependent. So make sure you kind of have an awareness of that. We typically don't recommend solely relying on infiltration if you have less than ½ inch an hour infiltration rate. Those are getting to pretty tight soils. So it's going to really limit the ability of that system to recover the volume. So it may have to integrate some under drains and connect that for some of the volume recovery. The subgrade compaction, there's a really kind of a fine point here where we need to have the subgrade stable for the loading that's going to be transferred from the pavement surface down to the soil below. But we don't want to over compact it to where we reduce that infiltration rate. And that's really sort of the fine line here with, we want to have it, compacted so that it's stable, but not over compacted to where water is no longer able to infiltrate. Permeable pavements can be really good, particularly in situations where it functions as pre-treatment, where you have run-on or impervious areas that run to it to remove total suspended solids and our particulates of forms of nutrients and other pollutants of concern. Some of the things just to keep in mind for sort of your regional and site considerations when we think about groundwater, again, keeping that bottom of that reservoir at least 2 feet above the water table. We want to make sure that the reservoir can basically recover its storage typically within 24 to 72 hours. And again, staying away from at-risk areas that may have a contamination risk. One of the things to incorporate into permeable pavement systems to be able to observe what's happening within the system itself is including an observation well. This allows us to see sort of how high the water is within the permeable pavement system. So this is a perforated PVC pipe that is installed through the entire length of the permeable pavement system. And so you can see basically the water level that you see inside of that will then be correspond to what the water level is in the system. So if there are backups within an under drain or there's a high water table, we would be able to determine that or identify that by inspecting the observation well. Oftentimes it's good to check this at least twice a year after large storms to make sure the entire system is draining down within its designed duration. And usually there is a cap that's either, if it's with a port in place, it's just level with the top of the pavement. If it's a block paver, oftentimes what I've seen is it's either flush with the surface or it's underneath a loose paver that can be removed out of the way and then accessed. But that has to be incorporated during the design and installation process. So we do want to make sure that our soils, our subgrade is structurally sound. but we want to avoid and not have it be over-compacted to where we are limiting our recovery of the volume. The existing soil grade, we want to make sure that this meets our density requirements. So oftentimes we're going to have some percentage of the standard Proctor density to meet. Once the aggregate layer, the reservoir, the choker course, or the bedding layer is put in, we want to make sure that there is no traffic. I'm sorry. We want to make sure there's no traffic until those layers are put in, because any vehicle traffic over that exposed subgrade could further compact that subsoil. If you do have a situation where that has occurred, and I'll show you some examples in a minute of some situations where they've had restrictive soils, clay soils, you can actually scarify or kind of break up that soil to improve the infiltration of that or mitigate that. If you have fill soil that's being brought in, so you've raised up a site and you want to put permeable pavement on top of that, it's recommended to compact that soil to 92% of that Proctor density for that subsoil. You want to fill and regrade any areas that are damaged by erosion, ponding, or traffic, so to address that. This is some studies that have been done, not as common in Florida, but we do have pockets of clay soils. And it's been, the research has shown that you can have some pretty effective runoff reduction, even with sort of slow infiltrating clay soils. And there's some ways that we can treat the soil so that we can optimize or maximize the infiltration rate of that soil that has some clays in it. Probably want to avoid any shrink swell soils, because this will create some instability issues. But if we have clay content and we don't have shrink swell soils, we can work within those situations if we can get up to 1/2 inch an hour. Or we can allow for whatever passive infiltration occurs and have an under drain that takes any excess away. Geotextiles and liners. So this is a kind of an important aspect to consider with permeable pavement systems. So one of the things with geotextiles is that there's always if it is a permeable geotextile, it, number one, should have an infiltration rate that exceeds 10 times whatever the infiltration rate of the soil is, so that is not the geotextile is not limiting to the storage recovery. But geotextile always has the potential to clog. So again, really important not to have any fines in the aggregate of the reservoir course, choker course, or bedding course that comes in, because they can collect at that threshold and seal that off. But it is important to utilize geotextiles on the sides and on the underside of a permeable pavement system, particularly particularly in situations where we don't want soils migrating into that reservoir course. We also have some situations where if we have poor load bearing capacity, we may want to prevent any water from going into them. So using an impermeable liner, and the sides of we want to basically insulate the sides and prevent migration of particles across that barrier, so that we don't fill in the reservoir course below. So the reservoir course, this is typically determined by the hydrologic design, not necessarily the structural design. So usually when you think about sort of the pavement, you've got a vehicle, but as it's distributing its weight through it, the materials, the pavement surface and the the choker course, the bedding course, by the time you have that much depth there, a lot of that loading has been distributed evenly to the subsurface. And so what actually becomes determining here is the hydrologic design and having enough storage to meet your water quality goals. So the reservoir course is typically this number 2 or number 57 open graded stone. The open space kind of ranges, but it's usually around 40%. That's where our volume of water stays. You may not need to include a reservoir course in very low traffic applications if it doesn't have additional areas running onto it. So sidewalks, walking paths, bike paths, you may just be able to get away with a choker course, a bedding course, and the pavement on the surface. But typically your heavier traffic loads are going to need 8 to 12 inches of a reservoir course. And if you need to have more than that, that's usually being driven by your hydrologic design. A couple things about installing the reservoir course. You want to install this reservoir course in about 6-inch lifts. So this allows it to kind of settle, and you can compact each lift so that it settles pretty well. You want to prevent any sediment during construction from washing onto that. This is when you're in a really vulnerable situation where if you have a storm event, think about this photo here, you got that pile of that stockpile of sediment there. Have a storm event, it's going to wash onto the permeable pavement, and you're going to need to basically clean that out, or basically take that, clean that, restore that, if you will. Make sure that the aggregate is installed to grade, and make sure you can put barriers around the perimeter until the pavement is fully installed, made of compost stocks, hay bales, silt fences, and so forth. You want to have excess geotextile if it's coming up the sides, and then cut that along the pavement so that it has a full coverage there. I recommend that the engineer or the architect basically inspect that subgrade prior to that reservoir installation to approve that the soil is in good enough condition. It hasn't been overcompacted. You can put a geotextile or reservoir aggregate layer immediately installed after the subgrade has been approved. If you're using a geotextile, make sure that we're using following the manufacturer's overlap recommendations, have adjacent strips overlap by at least 16 inches, and place horizontal soil subgrade and on vertical sides up the pavements. So you have all sides of that storage zone basically covered. You want to secure the fabric at least 2 feet outside the pavement bed. This is a good way to keep it anchored and preventing it from basically breaking away and falling down and leading to a failure. And then again, prevent any runoff or sediment from entering the storage bed during the installation. One way to improve or kind of create some resilience with your design is to have redundancy and overflow structures. So in this case, we see here in the middle, this is a porous asphalt insulation, and they basically have a reservoir. Their reservoir course comes out beyond the pavement and is open up above it to where any excess water can then overflow and then access and fill into the reservoir course below. Basically, it's a 1 to 2 foot strip that's filled with stones. You can also do sort of a catch basin to capture any overflow and discharge that to a reservoir or storm drain. And it can be used basically like a typical detention system. So at this point, I'm going to turn it over to my colleague, Jessica Brusso, to tell you about modular pavement systems.
Thanks, Eben. Before Jessica gets started, I saw we had a question come in the chat, so I just want to let folks know.
Absolutely.
I think for this one we're gonna go ahead and hold off our questions, our answers to questions until our Q&A at the end, just to keep things moving. And I did just want to share my screen one more time. I had one more Mentimeter question I meant to pose to y'all before Eben just gave that great overview. So we'll pretend that he didn't, and we are curious about knowing how much you know about pervious surfaces. So I'll give you a few seconds to go ahead and do that before I pass along to Jessica. And
should I go ahead and answer this question?
Going. I don't know. I think I might know where you fall on that scale, but oh, you mean the question from the attendee? Yeah, if you want to while they answer that. Yeah. Sorry, I thought you meant the Mentimeter.
That's okay. All right. I think that we're going to talk a little bit about some maintenance here in a minute. But oftentimes, if you can pressure wash this in spot areas, but unfortunately that actually drives those fine particles further down into the system, which could lead to further problems down the road. If you have the opportunity to vacuum those particles out, that's going to be a better situation. And I think Jessica's going to talk a little bit more about that.
Awesome. Sounds good. All righty. And then just to bounce back to our first question, just so we could see all our folks in the room, we got some local government staff, state government staff, some folks from the Department of Environmental Protection, a few private consultants, a few extension agents. So we got a nice diverse crowd today. And with that, we'll go ahead and pass it over to Jessica.
Awesome. Thank you. Make sure I get the right screen up here. All right, can everybody see? I think I'm sharing the wrong screen. Awesome. Worked well before.
Looks like that was the presenter screen, Jessica.
It was. Let me get the right one now that we're on. Okay. There's our slideshow. We got that?
Looks great.
All right, perfect. So today I'm going to be talking more about our manufactured pervious surface solutions, looking a little bit about design as well as maintenance and just what they are in general. So you've heard a lot of the details from Eben. So this is going to be a bit more higher level about each one of these concepts. All right, so first, just some general maintenance practices. Again, Evan just touched on this, but we like to do regenerative air vacs. Okay, so vacuuming, like Evan just said, is key. So you actually want to pull the particles up out of the pores of all these different surfaces or of the joints of some open joint papers that we'll talk about in a minute here. But you can do some pressure washing. It's really important to make sure you have the right distance away and the right angle to make sure you're actually pushing things kind of up and out and also preserving that surface, especially if this is going to be more of like a pervious asphalt or concrete that could be a bit more disturbed than just the joints in general, or the blocks in general, I should say. But there are deep cleaning methods as well. These won't be used as much as the others, but we do have that option. And this is kind of, when something goes for a while without any of these regular maintenance techniques, something else that can be done to really get a larger area completed and also areas that might be more what we'd say clogged. But as Evan also alluded to already, even when we're talking about something that's clogged, you're usually not talking 100%, right? So you usually have this great functionality still at getting a good rate of infiltration during a storm event. And I'm actually going to switch back just to my video. I do have a video here just of one type of vac, a regenerative air vac that also uses water. So I'll show you this. This is one of those ones that would be great for regular maintenance. This was an example that was done in Cape Canaveral. This is kind of what we call, it's kind of a porous asphalt, but more of an aggregate. It's called a FlexiPave. And let me get that video. I'm just going to switch over to what I'm sharing and see what we can get up here. Fast forward just a little bit here. Going very slow. This is for a demo. So you can see there's a lot of sand. It has not been maintained in a while. You can see kind of in between the wheels here, there is a difference in what it looks like. And that is a slide I'll go back to in just a second so you can see the after of this kind of first pass. When something has not been maintained in a while, it's actually imperative to make sure that you do more than one pass sometimes to make sure you get as much out as possible. So don't mind me as I switch back and forth. Okay. All right, so we saw the video and you can see kind of after, again, this was just after one pass. So you can see there's kind of a line of sand still there, and then they went ahead and did another pass through. All right, let's get into our manufactured solutions. So there are definitely a lot of different options here, and you can see just some of them up here. So we have our permeable interlocking concrete pavers, and Evan and I kind of went back and forth, but I still call the pavers with sand or pea gravel in between filled joint pavers, and refer to the other ones as these open joint paver systems that have nothing in between, these interlocking pavers. So there is a difference there, and we'll look at that. And you can see also, I mean, we have things that are concrete with openings in them for growing grass. We have modular porous concrete panels that we're going to look at. Some plastic grid systems are actually quite durable. So we're going to get into these different types of solutions. So again, our filled joint pavers, Evan, but the pavers are put down, and the pavers, of course, are not permeable in and of themselves, as Evan described before, but the water is going to percolate in between the pavers, in through that, either the sand or pea gravel, whatever is the case for those pavers themselves. So you can see a couple of different examples up here, right up in the middle, and also over with this walkway. So what does that do by filling that? Remember, it's for filtering, right? We do filter that way, but also for the pavers themselves, it provides that stability and load bearing capacity, and of course, depending on how they're designed for where they're going to be as far as how load bearing they can be. Now, infiltration rates in general for these end up being about 100 inches an hour. And you can see a couple different examples here too of more of the concrete with the open joints, where you can either put in the sand or you can seed them and do grass. Some of you guys might recognize a parking area over by the UF bat houses. So that is in the lower right-hand corner there. But it is going to depend, so you're going to have different infiltration rates depending, of course, upon what's going in between them. If you're looking at just concrete with grass in between it, then it's basically the same infiltration rate as grass would be, right? And then, of course, just depends on how that surface is maintained. Now, our open joint paver systems, now this is going to be different, where we don't have that sand infill or gravel infill. We actually see this open joint that's about 1/4 of an inch. You can also see that we have essentially, these gaps, that's where the water runs in between. They're large. These are actually about a foot square. They're 40 to 50 pounds each, so they are substantial. So they do not require to have, sand in between to keep them stable. They are stable by interlocking, and I should have, there we go, with 6 other of these blocks, or of course a retaining curb there. You can see they're also really good for parking applications. We'll see that a lot. You can see that in the upper left picture, as well as the lower right picture, where you can even do a different color that would differentiate that on-street parking versus driving lanes. So that is a very popular design to do. Again, just parking areas being the pavers themselves, and asphalt or whatever for your drive lanes. Now, I won't go too much into this. Evan did our deep dive, but just remember, we want that space above the seasonal mean high water table to be at least 2 feet to get that infiltration. And you can design based upon your contributing area. You can design the reservoir size underneath the rock, or you can expand, and we'll look at that too. You could use some type of underground storage system as well for an expanded and increased storage area. Rock does hold, at least number 57 rock holds about 40% void space, right? So we can actually increase that by using some other systems as well. As far as construction considerations, your base preparation is going to be very important. Again, making sure the layers are correct and according to the specs. If you want an underdrain versus no underdrain is going to depend upon your site conditions. So what kind of applications we look at for these in general include parking and driveways. I do have a question about roadways, and I get asked this question a lot. Can we use these for roadways? Maybe. In general, we like to keep drive lanes just standard asphalt. But again, as Evan talked about too, can you design to that? Yes, as long as the product that you're looking at can be utilized that way and does have that load rating, especially for the product itself, and then of course what's underneath in those layers. So in general, I would look at these if you really want to consider these for roadways. Again, examine the product you're looking at and everything else in the design, but also low slope, which has been talked about as well, and very low speeds. I mean, low density residential would be the best place if you want to try this for a roadway. As far as these go to, just the difference here between those joint filled pavers, obviously you have the gravel in between them. You usually have that leveling course before you have the base reservoir. As far as those other larger pavers I showed you, those open joint pavers, those can go directly on top of number 57 stone, and that does just have to do with their size. If we look at our construction, again, sub-base is going to be very important, and having that geotech, again, just kind of ping-ponging off Evan, what he said before, staging and sequencing is going to be very important for construction, making sure that if you're doing this in a residential area, that residents have access to their homes somehow and that they know what's going on. So that's really, really important. Associated geofabrics, this would come down to, again, what specific solution, manufactured solution are you using and what is specified on those plans. So also we can design it for infiltration, or we can also design for detention. It does matter though, of course, how much you have, again, before the seasonal high water table. But if you wanted to just kind of manage that peak flow and create these kind of areas, say pervious parking spaces, create these areas for the water to go to, at least to begin with, maybe you can't infiltrate that much. If you need to line it, you can with a 30 mil liner. Under drain would then be necessary, but also in different areas, you may have to do that buoyancy calculation. As far as our stone reservoir goes, you can see stone being put in the upper right-hand picture there, and another separate job, you can see compaction taking place. So that is going to be really, really important to make sure that base is prepared properly, so that the whole system functions as it should. You also want to make sure that you level. So this is important no matter what type of paver that you're looking at, that they're level and that the whatever is specified in the plans, that tolerance is met. So you don't have one paver here and one paver here, and this really big difference. But it is very specific on the different types of pavers, what that tolerance should be. It's usually like 3/8 of an inch, is very, very minimal. So moving on from there. We can also look at using that expanded storage, like I mentioned. So we can have our paver system, and then whatever we need for that base, right, that immediate base, and then we can put some storage system underneath. Now, the one that you're looking at here has about a 90% void space. There's others 95%. Again, this all just depends on specifications. You could put them over vault systems. There's that as well. So it just really depends upon your site conditions and what you're going for. But if you want to have that larger capacity, let's say this is under a parking area, that is definitely an option, and it is a way to really make use of more space, use less rock in that regard as well. Now, as far as maintenance is concerned, we can see what happens over time, right? With our joint fill pavers, we collect the sediment, which again, that's what that's meant to do. The gravel, the sand in there is meant to actually collect whatever's coming through, but then it tends to get clogged over time. This is especially true if there's going to be an organic source somewhere close to it. Again, Evan also mentioned that. So if you have leaves breaking down, if you have gardens that may be overflowing or something, you can get more organics there and get more sediment that'll contribute to clogging. So you can see actually both of these are exhibiting clogging here. But what can we do? Basically, for our joint filled pavers, if you're using any kind of a vac system, it would have to be very, very superficial because you don't want to disturb that pea gravel, right? But if you can do regular maintenance to keep things like organics off the top of it, that's going to be extremely important. As far as deep cleaning, and this is what would have to happen, say in this case here, we can see that ponding. You actually have to spray out all that gravel, back it up. So that's basically good as new. You just have the paver sitting there, and then you have to sweep back in more of that gravel that's necessary. Okay, so there's that extra component there. So it's not just removing what's there, but also putting in new gravel, so you have those joints filled and that stability again. Now, our open joint pavers, with our routine maintenance, again, regenerative air vac, it's going to be really good. We have what's called this spot cleaning, again, with the pressure washer, right? So here's an area, and we talked about before, and I have more pictures of it coming up. But essentially, we tend to see a lot more deposits when water's entering into that porous area. So the edge of the parking, or in this case, this is the radius of one street that didn't have pervious going to another. So we can see the deposits, we can see there's the grass going, so there's a lot of stuff there. However, if we move more towards one side of the picture where you can't see anything, right? That was just basically rain and some sheet flow, right? So you don't have to worry about that there. But if you concentrate this, again, spot cleaning with a pressure washer and a vac, just go ahead and do those areas that are receiving the organic material or sediments or whatever. If you do that more regularly, you don't have to worry about really deep cleaning. And you definitely don't have to worry about doing that whole spot or the whole area like that. If you do need to do deep cleaning, there are attachments that can be used with a big VacCon machine there. So you can see that head goes on, has some nozzles, high pressure, sprays in, and it's backing out at the same time. So that is what deep cleaning would look like. Just some examples here too. Again, more parking. I do like the pictures on the left-hand side because you can see that vibratory compaction is on top there, making sure everything's level and also compacted the way it should be. This is that roadway I was talking about. This is in Cocoa Beach. So you can see that was at low density residential, again, very low speed for those blocks there. We do have, again, parking areas, and both of these parking areas that are on the right-hand side, you can see we kind of have that run-on condition. So keeping those drive lanes in asphalt, directing the water, making sure it's graded so the water's directed toward those spaces, and using them like inlets. And we talked about this before, I think in our first webinar here, but we can start a treatment train with our pervious pavers, right? So we can get the water underneath. You'll notice in this, there's the pavers themselves, there's going to be the stone, and then there's going to be a storage system underneath. That does flow actually through a gabion wall that's actually filled with BAM material for denitrification and removal of phosphorus. So there's a really cool treatment train there. You can see the R tanks, or I'm sorry, the underground storage. No words, no. Anyway, so going in there and you can see kind of the final product as well. Plastic grid systems. These, I guess, in the past have maybe had mixed reviews or made out of different types of plastic. Some might be HDPE, some are LDPE, have a little bit more give. But the goal in general is to spread out the load up above, prevent compaction of the substrate below, right? So we see a lot of overflow parking lots that are just dirt or they're gravel or whatever else. And over time they become compacted and they have these ponding issues everywhere and nobody really wants to park there. So they help to stabilize that surface. You can see the difference in the upper picture between the left and the right of those two. So putting these down again makes a smooth walking surface and can delineate spaces that way. But that's going to be maintaining that infiltration. So preventing compaction, stabilizing surface, maintaining a good infiltration rate of whatever the gravel is really. And then of course, we'll get into the profiles as well, but very similar as far as having a base or reservoir there. As far as fill, you could use gravel, you can seed them with grass. Some of these can be driven on actually without anything on them. So you can see actually there was a fire truck on these panels there. And some have these essentially tiles or inserts that go in them that are made of concrete or recycled rubber. So you can see they have a different look, but still that plastic grid system, but the water's going in between the actual little tiles themselves. As far as, again, you're going to see a lot of the same kind of stuff here, but just think about that reservoir size and capacity. Consider that contributing area that's coming into there. Do the correct base preparation and the leveling. The leveling is really going to be key in a lot of these, and just making sure everything is functioning properly and you're not creating any kind of ADA issue there or trip hazard. Okay, so these types of panels, these ones go in as together and then interlock. There are some that are actually rolls that go out. Again, you can choose if you want an under drain, no under drain. But essentially you can, and I really like the picture of the leveling there. So it can be, that kind of labor intensive, but making sure you have that is going to be very, very important. Now, profiles can be deeper depending on conditions. We don't see as deep profiles here in Florida because a lot of times we have this, higher groundwater table. But you can see the difference kind of between the gravel filled versus grass filled. You can actually put some more soil underneath there, do a bridging stone too if you want. So a little different in Florida, sometimes a little bit harder just because of grass species, and that would be something more that Claire would be able to talk to. But making sure to get a grass species that's going to root actually through the grid itself and into the substrate below. So that's why you'd want to give it a little bit of substrate as well. Or you can put these down and you can actually kind of use this as a base and go above it too with some sod. These grid systems, they're the least maintenance intensive. Basically, you're going to inspect them for any loss of rock or fill. If there's grass, obviously you're going to be mowing it. But basically, you can use a leaf blower. This is obviously not the same types of pavers, but it's a picture I could find. And where our grids with inserts, you can actually back with a low suction. Again, we don't want to be pulling those tiles out, but you could also pressure wash in between, because remember the way those grids look, and I'll show you in a second, that'll help to kind of lift out anything. A lot of different applications for these as well. Parking, driveways, RV pads even. So remember that these definitely, and again, it depends on the rating of all of these products. But if you can put a fire truck on it, you can put an RV and different things. So they are good for things like road shoulders as well, which you'll see a picture of coming up. Pathways and trails, and even equestrian. So this is a really cool application for these. So I like to always throw it out there too. May not be as stormwater related, or you might not think about it that way, but hooves, they have a lot of PSI. So really good for horses in these areas as well, stabilizing their surface and allowing things to flow down there to keep their areas clean. Now, can it be used for roadways? I don't know if you'd ever see it in a roadway necessarily. However, I will say that I do know they use a certain type of these during or on military bases. And they are used for road shoulders. They're very good for road shoulders to prevent that rutting that we see a lot of times, especially if you're coming off of a turn. So I'll show you a picture of that in just a second. Great example here of a parking lot and a boat launch path that was done with using these tiles, right? The plastic with the concrete inserts. But then this boat launch pathway, which you can drive on, drop off the canoes or whatever, is done in the grid filled with rock. Different coastal implementations as well. So you can see the boat launch area. So definitely you have a lot of heavy traffic over this. You have even the area where you can park your boats there, park your trailers and everything. You can see how close it is. This is actually in coastal North Carolina, and it's post a hurricane. I can never remember the name of the hurricane. It begins with an H, so if anybody looks back, that's the one. And also you can see the road shoulder as well. So I didn't want to show that. This is obviously before, nothing's growing there yet. This is after installation, but that eco-harasser is right there. Now, our precast porous concrete panels, this is very interesting. Evan's going to go into the actual pour-in-place concrete. Again, I have the manufactured products here, so I'll be talking about these manufactured porous concrete panels. An advantage to these is that they are made in a facility, so they do have that QA, QC. They have those controlled environmental conditions, which make sure that that comes out a certain way. We know that it's hitting the infiltration rate. We know that it's hitting specific strength goals. So that takes kind of the guesswork out of some challenges you may have with a pour-in-place porous concrete. They are HS20 load rated. And as you can see, these are very unique in the fact that, again, they're modular. They are going to be put in with a front loader. They have hooks in them that come out afterwards, but they can be used again if they need to be removed. Really great for porous gutter lines, parking areas, and the like. Radius as well, sorry. So basically anywhere water can stand and collect, really good for that as well. I love this picture here because you can actually see the profile and you see what an underdrain looks like. It's going somewhere, it's going to connect somewhere. When you design these, if you design with an underdrain, they can be designed to go into a number of different areas. Maybe they go into a rain garden to discharge. Maybe they go into the catch basin. So just up to what you want to do with the design. You can use expanded storage underneath if desired. You can actually see that in this bottom panel or bottom picture here, which is actually showing this on a slope. So using a porous gutter line on a slope, but if you do that, you may need to actually use some underground check dams in between. Very exciting. New York City is actually moving forward with many miles of this concept of this precast porous concrete gutter line. So rather than, they did the rain garden thing and they did a lot of them. And the problem with that was they were very hard to maintain because, you know, you need the staff to do it, right? As an alternative now, they are implementing, again, miles, I forget how many miles, but it's a lot of these porous concrete gutter lines with, as you see underneath in red, those are going to be that expanded storage underground. So essentially, as water's flowing down the curb line, it's actually infiltrating. And I'll show you a video of that coming up as well. As far as maintenance is concerned for these, again, very repetitive here, but you can do that pressure wash and back. Be careful with that. Be careful with the angle. There is a regenerative air vac. There's a ride along you could use too, which is pretty cool because it's actually the width kind of fits this type of panel perfectly. But this ride along can actually be outfitted with this other deep cleaning attachment. Of course, though, notice deep cleaning attachment is attached to a vac truck. So it is a definitely more intense process when you're doing any type of deep cleaning of these surfaces in general. So that's why the routine maintenance is going to be more, you know, what you want to do really. Now be careful. I will caution you on these types of surfaces, a wire broom, like a street sweeper that's non-vac, actually might drive particles in or can hurt the surfaces. So I just caution on those if these are being implemented in different areas. Just more examples here. Our porous gutter lines we talked about already. Water catchment next to street trees. So I thought this was really interesting application. They used these modular porous concrete panels in the sidewalk as part of the sidewalk, which they can be. And you can see the bottom picture on the right-hand side is the sidewalk as well. But essentially being next to where a street tree is, we can now kind of direct water towards that tree as it infiltrates. It can go and diffuse that way. Parking areas, again, remember just that kind of run-on condition, not the whole thing. And this is an example of these in Cocoa Beach. So this was going to be was a standing water issue long-term. The water, and you'll see a video in a second, but the water would come actually from both directions. This was just the low point of the street. So these residents were not too happy about having this large puddle that pretty much never went away in the summer months, especially. And you can see their parking's right there. So the city decided to implement these panels. They put 7 in a row, put a nice ribbon curb around them, and the water does infiltrate. Notice there's a lot of sand. This is right across the street from the beach. So there is that, but I'd like to point it out because it's still infiltrating the water. Remember, if you have this whole surface that's pervious and a little bit of sand is there and sand still has a really good rate of infiltration, you're still infiltrating that water. And that is going to be during an active rain event. So you can see, again, there's the sand. Water is actually coming from both directions. And I will show you a video of this. I'm going to end with a few different videos. So I'll show you 2 little ones from Cocoa Beach from that project. And then also one of a gutter line application in California. Okay, so this is a shorter one just during that rain event. Oh, make sure you guys can see it. As you can see, the water is going into, and it's slowly creeping into the panels, but also there are little gaps in between those panels as well. And as the rain got heavier, what you're going to notice here, there's a lot of water. There's still a dry spot in the middle right now, but there's a lot of water in general. And it's slowly creeping, but notice it's coming from both this direction. So it's coming from the west and it's coming from the east. Now, remember the goal of this and what's important to keep in mind is that this was for standing water. So after the storm, water went away really quickly. But it does, because it's coming from such a large contributing area to a relatively small solution. This is not going to be the same as doing a whole gutter line with this type of solution, which I'll show you next. You can still, it's flowing into it and in between the cracks. Kind of looks like a drain the way it's like swirling because it's going in still. All right. And the last one I want to show you guys is going to be from California. See those atmospheric rivers that they get. So the water is traveling down, and notice the further down it gets, down this porous gutter line, that it's infiltrating as it goes. So the flow starts to slow the further it gets down the porous gutter line. All right, so hopefully that was some good examples for you and informative. Evan, I'm going to pass it back over to you for the porous asphalt and porous concrete.
Thanks, Jessica. Before Evan gets started, I'm just going to pose one more Mentimeter question to y'all. I will get it up on screen for just a second, and then I'm going to take it down so that Evan can get started. But this one will be a just a quick little quiz question. So let's see, it's starting right now. Here we go. Should have about 30 seconds to complete this question. And then we can check out the results and let Evan get started with his presentation. All right, so we were asking about main barriers that folks have experienced while attempting to implement pervious surfaces. It looks like we have some folks with cost concerns acting as a barrier, lack of knowledge regarding functionality as a main barrier, some regulatory barriers, as well as some maintenance concerns. So hopefully this webinar helps with some of those. And with that, we'll pass it back to Dr. Bean.
Thanks, Nathan. So I'm going to try and wrap up here, get through these pretty quickly. So porous concrete. So this is essentially, there's a few different terms that are used here, but it's basically referred to porous concrete, permeable concrete, or porous pavement. But essentially it's the same stuff. It's open graded aggregate with cement paste. And those interlocking aggregates that are bound together create interlocking void spaces that allows water to drain through, and that's how it's done. And you can always identify it because it looks like a Rice Krispie treat. The aggregates tend to be, sort of 4 to 10 or 5 to 10 millimeters, half a centimeter, a quarter inch, and so forth. The porosity of the porous concrete itself is 20%, which is slightly less than what you typically find in the reservoir, which is around that 40%. And the infiltration rate of this is comparable to other permeable pavements. We're typically looking somewhere, on the order of 200 to 3,000 inches per hour. So even if, we had the most intense rainstorm, we wouldn't be having anything near that. So really, when you start to think about, a 1-to-1 ratio of impervious to pervious, you're looking at, double the rainfall rates. And let's say, 10 inches in an hour. That's pretty intense rainfall. That would be 20 inches per hour. We're still nowhere near 200 to 3,000 inches per hour. The issues with clogging come up whenever we don't maintain for a long period of time, and that infiltration rate, whatever the type of pavement is, kind of slowly declines, and it never seems like it's having an issue until it really gets to where it's really clogged and not been maintained, and that's when we have to address it. So with pervious concrete, you typically have 4 to 8 inches of the concrete itself. Again, 20% voids. And then we typically have sort of an open graded choker course that rests on overlying sort of that reservoir course that has typically about 40% voids. One of the main things with pervious concrete is just making sure that the installation goes well, so that since it is poured in place or installed, making sure that the quality of that the interlocking void spaces is cured in place there. You typically have some fairly similar applications with other types of permeable pavements, parking areas, highway shoulders, full depth roadways we can do, high volume wear and course overlays can be applied. But we also have sort of non-pavement uses as well, or like drive lane, I should say, curb and gutters, hydraulic structures, erosion protection, and so forth. Very well suited for low traffic areas, whether it's parking lots, walkways, paths, or pedestrian areas. Playgrounds even can be be used for in that way. Depends. I mean, it is a pavement surface, so it depends on what you want to kind of do with that surface there. But again, another example of heavy vehicle on permeable pavement in the upper left-hand corner. One of the benefits of pervious concrete, because it is lighter in color compared to conventional asphalt, which is typically used, is that there is a bit of a heat island effect that's been shown. And so it helps with evaporative cooling. And there's some functions there with helping to cool the surrounding area by by reflecting that heat rather than absorbing it and increasing it. So when we're dealing with the porous concrete mix, it's really important that this is designed correctly and that we don't have any issues with drain down, or basically issues with the curing process. Really want to have sort of a narrowly graded coarse aggregate, balance the cementitious paste volume for durability so that you have give and take there. You want to make sure that it is workable. The porous concrete is workable without having the paste drain down. So if you see the pictures on the right, you can have excess, if you have excess paste, excess cement, you can see what happens on the far right on the bottom, where you can have that paste drain down basically and seal the interface. And then we have an impermeable bottom layer. So that's really important to make sure that we don't have too high of a water to cement ratio and the paste is not excessive. As with any type of permeable pavement, highly recommend getting experienced certified installers. You can pre-qualify bidders that by requiring they have certain training or certifications for doing installations. One of the other recommendations, if you're pouring stuff in place, whether it's concrete or asphalt, is to request a test installation or a test section be poured on site. That can help to identify any issues with the full installation. This is a really great kind of step to include in the installation along that process. National Ready Mix Concrete Association has 3 levels of contractor certifications. They have sort of the initial technician and installer, and then sort of the highly specialized craftsman. So just kind of looking, if you go on their website, they can give you a list of installers for different areas around the country. Oh, and one other thing is to also consider having the installers recommend previous installations so that you can go visit and look at the quality of that installation after some of the durability, after some of the wear on that site as well. One of the things that has come along, and I'll touch on this as well with porous asphalt, but additives into these pour in place options has come along quite a bit in the last 10 or 15 years. So in addressing workability, by mixing in sort of water reducing admixtures with hydration stabilizing admixtures that can help with this situation. Typically, we only have about an hour between when the mix is created and when it needs to be put in place. We can increase the durability and workability with air entrainment and adding in latex additives, typically a small fraction. Also, utilizing polypropylene and cellulose fibers can help to strengthen the binding of the aggregates and cement. And then there are some remediation options for when we have too wet a mixture or too dry of a mixture. One of the things that I think I'll touch on a little bit more is that whenever it's being cured in place, the cure time is very critical to having a successful installation. And that's why it's really important to have someone who's with experience to install this. If you have, if the mix is too dry or it dries and cures too quickly, it becomes brittle. And essentially you can have what we have on the bottom figure, bottom image on the left, where it really kind of breaks down, crumbles, and the added traffic of the raveling of those particles breaks down and you just generate sediment and it clogs itself. The other side is if it stays too wet for too long or it has too much cement. And you saw in the previous slides where we had the drain down that occurred and it kind of sealed the bottom. And that can really reduce the performance as well. It can still function. You sort of have the storage that's just in the pavement itself, but then it takes a while for that to laterally flow out of the system and into other areas if it's completely sealed on the bottom. Costs, and I'm going to note that these costs are from 2016. Quite a lot has changed, obviously, in our supplies. So obviously check with local suppliers on these, but just to kind of put in ballpark sort of what your general materials versus it being installed are. Porous concrete typically runs $2 to $6 per square foot. Installed fully, $6 to $10 per square foot. So whatever that inflation factor is, apply that to it. But this at least gives you sort of a relative estimate of, okay, material costs is this, and our installed is usually going to be probably about twice what that material cost is. But it's important with all these types of permeable pavements to understand and account for the offset of other storm drainage infrastructure, whether it's stormwater pipes, inlets, land area for stormwater basins, ditches, other things, and your maintenance costs can be reduced as well if you're making sure that you're not having sediment loadings that are contributing to the area or having too high of an impervious to pervious ratio. With the installation, you want to make sure you have either wooden or concrete forms that are rigid enough so that when you put it in and when you're driving over it, that they're not flexing and deforming. So it's really important to do that. With discharging and installation, number one, porous concrete is not pumpable. Okay, so you're not going to be able to pump it. You've got to kind of place it in there. Good idea to spray the aggregate base, that choker course, with water so that there's some moisture on the bottom side of that and it's not just taking the water out as it's curing. Just kind of trying to stay on time here. When we're putting it in, you're making sure you are you put it in, you want to screed it, basically hand placing it or putting it hand placing it and then roller screeding it so that it is even, basically running across the top of your forms. There are some other ways that it can be installed, but be sure that that is approved by the architect or the engineer who's doing it. With finishing the sheeting, this is typically how we control the curing process. Make sure that the entire area is covered with heavy polyethylene sheeting or other impermeable material. This is important to retain the moisture so that we don't have that accelerated curing. You want to basically unroll the plastic over the fresh pavement system, over the full width of the forms, and make sure there is overlap between the two areas and seal any openings in those sheets. There are some ways that we can slow the evaporation that is coming off the pavement surface by using certain products. Whatever the products you use, just make sure you're following the manufacturer's application rate. Curing, this is just putting it into the timetable of the whole project. Just straight curing requires about 7 days. So 7 days without traffic. Now there may be some different mixes and ways that you can kind of, avoid doing that or taking that long. But full curing to allow for truck traffic takes about twice that long, 14 days. So once it's fully cured, then you can go into sawing the pavement. You just want to make sure that it's resisting the raveling and any cracking. Operation and maintenance, making sure that we do sort of regular vacuum cleaning to remove the accumulation of sediments, making sure that if there are structural failures on the pavement, such as raveling or just collapse in a section, that can be basically spot addressed by doing a full depth patch, full depth of the pavement itself, not the whole profile of the permanent pavement system. But that can be used just using conventional concrete. Yeah, just making sure that during construction or right after construction, the areas that are adjacent to it are stabilized. Just going to kind of go through real quick. Porous asphalt, very similar to porous concrete. Some of the main things that are different here, we have open graded friction course is typically 1.5 to 2 inches. And then there is ATB, which is our asphalt treated permeable base. This kind of works as a choker course, and then you have the reservoir course down below it. Another type of porous asphalt is pervious friction course. This is typically just a top layer over dense mixed asphalt or your conventional impermeable asphalt. This allows water to drain through the very top surface of the pavement where that's in contact with the tires and flow laterally through it off the site without having hydroplaning. Just going to kind of go through this pretty quickly as we are out of time. The structural design here really focusing on the flexible pavement design. So making sure that our different layers are accounting for its thickness and its structural strength to total the actual loading that we need for the traffic that is going on, whether we're doing parking, residential streets, heavy trucks, and so forth. The mixed design is kind of just looking at the different particle sizes and including certain types of binders. One of the main things that has changed, particularly with porous asphalt, is the inclusion of better binders that help to prevent the temperature deformation that can happen with porous asphalt. And then the temperatures are really clear. The temperatures are really critical during the curing process. And it's really important to do quality control by taking samples and analyzing those from the installation site. You know, to think about this is going to be put down and be used for decades. So it's important that you take the opportunity to do field testing of the porous asphalt so that water can go in, but also taking cores and analyzing that in the lab by a third-party system. Typically, the asphalt that goes down is going to be, you want this to be between 275 and 325. Notice the temperature on the right is not in that range, and this is because it has cooled slightly during the installation. But this is sort of where the rolling and other types of finishing can happen during the installation process. So you want to compact that asphalt while it's hot. And the compaction should be, about 16 to 22% void space after that asphalt has been compacted. So you do sort of breakdown rolling between this 275 to 325, and then intermediate between 200 and 275, and finish rolling while it's still 150 to 200. You don't want to have the rollers be parked on the freshly placed asphalt, as this can deform the material. And then using different shuttle buggies that can kind of help with the temperature, maintaining the temperature of the asphalt as it's installed. Important to roll it initially after installation, and then also kind of doing some quick infiltration measurements. You can do this. There's also sort of a single ring infiltration test. In this case, they're just opening up a fire hose and looking at how wide that pool diameter is on the surface for it to basically completely infiltrate. Some critical elements of success that I think really apply to a lot of our different types of permeable pavements, making sure that you have good quality assurance during the construction phase and being sure to have really well thought out construction phasing. Keeping in mind the long-term maintenance considerations during the design phase. So maybe you have the drive paths be permeable rather than the parking stalls. That can help with doing maintenance. Particularly if it's going to be very difficult to have all of the parking stalls empty at any given time. Making sure that the engineers and the installers are qualified to be able to install this. And whether it's asphalt, making sure that the asphalt suppliers are familiar with DOT or other agencies' quality work, what they're expecting from that. And it's really important with to have the experienced installers who know how to install this and can do testing. Some things that are kind of I think important to address are that there have been some poor installations in the past with porous asphalt. Advances in the mix design have tried to alleviate some of this. They can be very effective with water quality and hydraulic performance as far as trapping solids and routing water and infiltrating it. The structural load can be actually, because of that that sub base, that's sort of a mixture of the choking layer and asphalt, can have actually a stronger loading performance than standard asphalt because it's got a thicker profile. And there was a large number of installations that were just poor and the mixes were not well. And I think that gave sort of porous asphalt a pretty bad name, but that technology has really matured in the past 10 to 15 years. So a lot of these options are available. Some things to consider as we kind of wrap up here with all types of permeable pavement installations, not just porous asphalt. Things to be cautious of are small applications such as single driveways that are difficult to really get construction quality control. So if you're doing that, try and think about how you can get the quality control or do that as best you can. It's just really difficult to do small patch installations all at one time. So maybe you can do those at multiple in a development. Mixed use pavements with small pocket applications, again, sort of those very small installations. It's hard to ensure that you have a small batch to ensure the quality and so forth. If the project doesn't have construction quality insurance, that's a big red flag to make sure that they're not willing to pay for or do the quality insurance on the installation. If the project doesn't have long-term maintenance considerations, or if they're not looking for qualified designers, suppliers, and installers, again, you're working with some folks who maybe just aren't familiar with the criticality of those aspects for installation. And then looking at areas that might be subject to runoff from nearby impervious or tracking sediments on where that hasn't been really accounted for in the design and the siting. So really making sure to try and limit the sediment that's being generated so that it doesn't have to be trapped on the permeable pavement and have to be collected there. I know we're going over time a bit. I do want to address sort of a few myths that are pretty common for permeable pavements. The first one is that a lot of times we hear that permeable pavements can't support heavy vehicle traffic. Well, in reality, the structural design for permeable pavements can be adapted to almost any vehicle loads. We've seen it where it's been used for emergency vehicles at the facility, where they're being at a fire station or other type of facility there. We've seen where this has kind of been used on military bases where they've actually used it to support tank traffic as they load up onto vehicles and other transportation. The main thing is to avoid those structural failures by making sure to use certified installers and performing construction quality assurance, checking that the installation, the materials are meeting spec as it goes down, so that you have some confidence that the system is going to perform as it's designed. Another one is that permeable pavements will become impermeable. Well, permeable pavements are all effectively filters, and so filters, they clog, right, when they trap material. But filters can be restored by removing that trapped material, and so it's important to do that and to do it proactively. Oftentimes what happens is it seems like the permeable pavement is working fine, even with some accumulation of sediment. And so it's like, maybe we don't need to do the maintenance on that. And then overall, it just slowly continues to decrease in performance. And then at some point, it gets to a point where it's basically kind of sealing, and you start to have some ponding or puddling. And really could have been avoided by continuing to do just regular maintenance. Now, that kind of a situation can be addressed by doing restorative maintenance, where you really just do that intensive multiple passes of the vacuum. But it is difficult to restore it back to its full capacity. Porous asphalt can't be used in Florida. Sort of the idea that porous asphalt will melt in Florida's heat. That's not necessarily the case. We've seen some big changes in the mixes with porous asphalt over the years. They have really improved, particularly with some of the additives that help them to retain their strength in difficult high temperatures environments. So the past failures oftentimes are due to poor design, installation, maintenance, and so those aspects. And it's actually becoming a common option, common relative to other types of permeable pavements, in some areas of North Florida particularly, and we see it particularly on bike and walking paths. University of Florida has part of their walk paths around the campus around Lake Alice is porous asphalt actually. And then permeable pavements are too expensive. So permeable pavements on a square foot area compared to conventional pavements are going to be more expensive. However, they are most useful or most cost effective in high land cost situations where that gray infrastructure and ponds can be reduced. And you really have to kind of take into account all of the costs that are, balancing within the changes to the whole stormwater system to evaluate the costs that might be there. Another aspect is that you don't have to do the entire pavement area as permeable. So typically we see sort of 50% impermeable, 50% permeable, so that 1-to-1. But we have, you can go as high as 5-to-1 as ASCE recommends. But this does just keep in mind if there is a sediment loading coming from that impervious surface, that is going to accelerate your clogging. Okay. Just want to note real quick as a resource to just remind you of, if you want to go on to ASCE's website, this is a reference where a lot of the content that that was shown here today comes from, and you can download that as an electronic or as a physical book. And so with that, I will turn it back over to Nathan Jagoda.
All right, thanks, Eben. I want to thank everyone for sticking around today. We do have a few questions in the chat, so we'll go ahead and do that Q&A. We definitely understand that we went over time a little today, so if anyone needs to jump off, no worries at all. This webinar is recorded, so you can always follow up and catch the recording if you missed this Q&A. But with that, we'll jump into the Q&A and see if we can answer these questions. So our first question is from Alberto, who asks, how is maintenance of these systems done as they clog with fine particles? How often do they typically require to be maintained?
I could take that one. I think that the maintenance, it's going to be site dependent on the sediment loading that is coming off of your site. Without, just as a broad generalization, we recommend vacuuming it once a year. But if you're in a coastal area that has a lot of windblown sediment, you might have accelerated, might have accelerated sediment accumulation on the surface. So you might need to do that 2-3 times a year to really kind of keep it under wraps. At the same time, if you have a really clean site that really isn't accumulating any sediment, maybe it's just, maybe you're just getting roof runoff and there's just not a lot of sediments that are coming onto the pavement, then you may not need to do it on that annual basis, but I would be very cautious about going more than, really going less than once a year on that, because it will, slowly it will accumulate and sort of clog, and it just gets very difficult at the end to, once it is clogged, to restore it back to its performance.
Awesome, thank you. So our next question from Daniel asks, how willing are the water management districts to start permitting GI solutions such as permeable pavements as primary treatment and storage instead of only relying on wet ponds? It would help urban developments to have more fine-grained stormwater solutions that are permittable. And then his follow-up question was basically, will the new DEP GSI manual be adopted by WMDs?
Well, I don't want to speak for the water management districts, but we look at sort of what is proposed with the new statewide stormwater rule. The FDEP has adopted, has not been ratified yet. Essentially, we're transitioning from a technology-based standard to a performance-based standard. Okay. And essentially what we're seeing is that you're not going to be able to meet the load reductions for nitrogen and phosphorus just by doing stormwater ponds. It's going to be cost prohibitive to do that. So you're going to have something that's more, you're going to have solutions that are more basically aligned with this infiltration practice, or the filtration, the treatment train with Green Stormwater Infrastructure in line maybe with a wet stormwater pond. The DEP is in the process of working with the water management districts to update the applicants' handbooks to have this kind of these technologies in there. And so they actually will have in volume 1, the statewide manual or the statewide handbook will have a whole library. That's what Appendix O is proposed to be, is a BMP library of options for having nutrient load reductions and having pollutant load reductions and so forth. I'm not sure if which manual is being referred to here. If that's, we're working on a manual that deals with sort of some green stormwater infrastructure and low impact development. So the handbook, the applicant's handbook is going to be updated to address those additional techniques and practices that we've presented, permeable pavements being one of them. Our GSI manual that we're working on in coordination with DEP, I don't know that would be up to the water management districts if they wanted to adopt that, but it would be basically guidance for designing these types of installations and these types of practices.
Awesome. Thank you, Dr. Bean. And with that, I want to thank our subject matter experts, our presenters today, Dr. Evan Bean from the University of Florida and Jessica Brusso from Ferguson Waterworks. I think we were able to pass along a lot of useful information that hopefully helps everyone. And I want to thank all of our attendees for sticking with us and participating in this webinar. We appreciate your participation in the Mentimeter, and we plan to keep that going through the series and hopefully ask some good engaging questions and learn a little bit more about y'all as well. So with that, I think we're gonna call it a day today, and I want to thank everyone, and I hope you have a great day.